Good morning. This is Chaim Yitzchak Michael, the Levi couple Harry Gersh Zeitz, minus a few that aren't legal anymore. Cha. Hello. So, today is all about why you will never travel faster than the speed of light. So, to have as assistants, today we have orange hair pen, blue haired pen. Now, let's say Let's say, let me use this pen instead. That's better. Okay. Let's say this. Well, before we go and describe this, let's first describe the boundaries. This is the one direction of space, right? This is, okay, well, let me put it like this. This is a one dimensional, but you can go back and forth, up, down, right? But that's the only direction you can go is up, down, right? Can't go left, right, out, in, any of that, right? It's just up, down. And that's space. That's one-dimensional space. Time, however, as it's coupled to space, right? It's coupled. So we have an understanding, a relationship between space and time. Now, time, you can only go in one direction. Obviously, theoretically, if you were to go or go faster than the structural speed limit of our universe, which this is what I'm about to go into that why you can't. But theoretically, if you were, you would be dealing in a different time, like this is negative direction of time, and I did that in another video, I believe. But anyways, just to stick to the video, because time is of essence for me today. Anyways, so let's call this we can call this basically just the speed of light, right? This is in the middle, exactly halfway between the time axis and the spatial axis, right? And so think about this is just representing a relationship between space and time, all right? The light cone, or the way that I draw it, is just a line light, but it's essentially, you can think of it like a cone, because once you get past the speed of light, or the structural speed limit, then you start to approach in infinity. You never get to infinity, but that's where Planck space comes into play versus Planck time. It's another thing. But once you get past the boundary of the speed of light, you start getting into what's called the space-like region. Because once you hit that, which you will never because of Planck's space, or Planck's length, I should say, Planck's length. But anyways, imagine if you were to reach this, like this. There's no time coordinate at that point. There's no relationship, because it's literally, time is at zero, right? But so basically, yeah, the speed of light, all it is really just a conversion, basically to help us understand the relationship between time and space. And you can clearly see, like, once you go in this direction, right? By the time you get to the end of here, right? The coordinate that represents space also gets there, right? But it also reaches time. Now, this is the funny thing. Let's say you were to accelerate, meaning your time contracts, right? So as you're going forward in space, right? There's less amount of time per space that you're going. Like if you're running, like let's say you're running, and then you decide to accelerate even quicker than what you were running, right? It takes less time to get further, right? So when you decide to accelerate, and this is where the meat of the whole thing is, when you decide to accelerate, your coordinates, instead of, let's say, for example, being here and here, right? This one still stays here, but if you start to run faster, this one, instead of being here, it will be here. Like just, for example, right? So it'll be shorter, contracted versus dilated versus time dilation, time contraction. So same length of space, shorter amount of time. So what does that do? So now that the boundary has been redrawn to be over here, you have a new square boundary to then what is half of that new boundary? Still the speed of light. And so why can you never travel faster than the speed of light? Because even if you were to accelerate to try to go quicker than the speed of light, the goalpost is moved. Every time you create a new boundary, the speed of light just goes along with the new boundaries. You can never approach the speed of light unless, and here's the thing, you create a baby universe. So by creating a baby universe, by introducing a new energy, stress energy to our universe, you can have certain knob dialing effects, right? So if you create a baby universe with with its own structural speed limit, aka its own speed of light, that what the fastest particle can travel at its structure, right? Let's say it's slower. It would have a different set of effects on our universe versus if you were to just if you were to create a baby universe in whose structural speed limit is faster than ours, right? It would have a different set of effects than if it were to have a slower structural speed limit, aka the speed of light. So, if Earth flat or triangle, I don't know what to say to that. Anywho, yeah, the comments here are very interesting. If light enters the black hole, will it escape the other end? Well, this is the thing. That is very speculative, what happens in a black hole. We're trying to work on it. So, with that said, back to the video. So every time, so with the baby universe, if you create one that has a new baseline, what I call lambda 0, it's the baseline offset that gives the structural memory to everything else. But when it comes, so when you basically, if you create a baby universe that has a slower structural speed limit, a different lambda 0, and a few other things like stress energy tensor, you would have, it has everything of its own. You can use that as basically, essentially, as knobs on our universe to kind of like think of it like a sink flowing in energy. Think of the type of technology we can build from this shit, where we create a new source of energy based on curvature memory. So yeah, that's my work that I'm doing right now called Horizons as Dimensional Interface Theory. Or framework right now, HDIF. It's a new set of physics and also engineering, applied science, that I'm working on. I got accepted into the theoretical physics community in Zenodo. It's part of CERN, those particle smashers. And my goal is to get investments, but also to get my work peer-reviewed by a journal to validate it, because if it's false, because if it can be tested, if it's false, then we at least know we move on to what is a better explanation. But if it is, if we are successful at laying this as a groundwork, then we will have a new language for geometry, and be able to build new technology from it. And build a world where whatever problems we have now those are just folklores. thousands of years from now. That's what I'm working on. I'm looking for people who are willing to work on this project, right? This is something that needs as many hands on it as possible because this is the future of humanity. Einstein said, God doesn't play dice. Well, he technically does. He just has his fucking fingerprint on all of it, so he leaves a trace behind so he can fucking cheat. Everything is determined, and what looks like randomness is just damped memory. Anyways, with that said, I'm going to be late for work. Time is of essence, so peace.